that I minus k can be divided by 7. And if that's true, then IRK, and we're trying to prove that, right? Trying to prove that IRK. Because we know IRJ, we know JRK, and we're trying to prove that IRK. Right? So that means we have to show that the difference between I and k is divisible by 7. Well, and we can take the two previous results. So now look, I minus k is the same thing as I minus j plus j minus k. Right? Because these j's just cancel, so you're just adding 0, which doesn't change anything. Okay? So you can rewrite this as this. This is the trick. This is the intelligence. Creativity in the proof, right? Okay, so this is equal to this. Now, I minus j, we know is 7p. So for I minus j here, just put in 7p here. And j minus k here, we know is 7q. Okay, so for this, write 7q. Now we've got 7's in common, so take the 7 outside, so I'll get p plus q. Now p's an integer, q's an integer, therefore the sum, p plus q, also an integer. Alright? And that means that this has a factor of 7. In other words, you can divide this, with 0 remainder, by 7. Okay? Therefore, this thing, k. So we've proved the third property. We've shown that this is transitive. Now we showed earlier that it's reflexive, symmetric, and now we've just shown it's transitive. So it satisfies all three, and therefore this relation here is an equivalence relation by definition, because an equivalence relation is a relation that satisfies those three properties. Okay? So this relation is an equivalence relation. Alright, I must say, with my sort of math background, it sort of feels a bit funny for me to sort of stop here. It's like math courses would just be the beginning, and then you'd sort of find all the sets of all the elements that are equivalent to each other, and you label them an equivalence class, and then you have all kinds of theorems about equivalence classes. Okay, but this is computer science, right? Very probably you're being fed only what you need for the computer science. Right? You don't. He's the author, Sipser, I assume, is only giving you what you need. He's not giving you stuff for its own sake, right? Just the bare essentials, the minimum required for the course. And it's 400 pages, and believe me, it'll get tougher. It's not as though it's trivial at all. I mean, the proofs much later into the book. I keep warning you of this, so you don't. After these few sessions, you get the impression, this is not too hard. It's right now I estimate it's at about junior level, but it'll get harder. It'll go through senior level and then get well into master's level, and inevitably some of you will drop out. Right? That's just the reality in my experience. But if you're good master's level students, you should be okay. Right. Okay. Now, so that's finishing off equivalence relation for the book and these preliminary tools. Now, graphs. What's a graph? Well, it's essentially just a bunch of points and lines connecting them. That's the essence of a graph, right? So, a bunch of points, or if you like, little circles, sort of the same thing, and then lines that connect. Usually straight lines, but they don't have to be curved lines. But just lines that connect some, and in some cases all, all the points. But usually some pairs of points or little circles are not connected, right? But that combination of points and connecting lines, that's a graph. That picture that you draw, that is a graph in a technical mathematical sense. Okay. Now for the next couple of sessions, you're just going to be thrown a whole bunch of definitions that you need to memorize. Right? Believe me, you'll need them. I haven't checked strictly to see if there's any waste. Like, is he Sipser, the author? Is he tossing in stuff just because he thinks it's interesting, but later does not get used in the text? I don't know. I haven't checked it through in that level of detail yet. But my feeling is that there's very little, if any, redundancy. He's just giving you that will be needed later in the text, which is fairly sensible sort of thing to do. All right. Now, so expect now a whole bunch of definitions in regard to graphs. Okay. So firstly, those little dots, those points, they get their own label, and the lines connecting those points, connecting 2 points, also get their label. In fact, they get 2. Right. So the dots, or the little circles, it's easier to write little circles when explaining things. Now these dots or little circles, they are called nodes, right? And the lines connecting them, they're called edges. Right? So now nodes, the dots, they have another name as well. So just 2 names, synonymous. They mean the same thing. Vertex. So a node or a vertex, same thing. So 3 bars here by definition. And we will use the V of this word vertex to label a set of vertices, a set of points, set of nodes. Right? So we'll see this V crop up, occur a bit later. Okay. So you can label a graph. You can specify, you can describe a graph by its nodes or vertices, same thing, and its edges. A set of edges. Okay. Now, so nodes and vertices, or node and vertex. Okay. They're the name given to your points or little circles, and the lines connecting them are called edges. Okay. All right. Now, there are a whole string of definitions, terms that you'll get in the next few sessions. Now, the degree of a node or a vertex, I'll probably just use node because with just one syllable it's easier, and vertex won't use that so much. So I'll just talk about nodes and edges. Okay. So the degree of a node, what does that mean? Well, it means how many edges touch it. Like, for example, so the degree of node, by definition, this 3-bar sign it's the number of edges at that node. Well, here's a node, right? It's got 3 edges here, at the node, or touching the node, meeting the node, whatever. Okay, and this node, it has 3. This node has 3. This node, in fact, all of them, all 4 nodes in this graph. The whole thing is the graph, right? So this graph of 4 nodes, each one of those nodes has a degree of 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? So they all have the same degree, and that degree is 3. Now here's another graph with 5 nodes, and the degree of each node is 2, right? Because there are 2. Now what are these called again? Can you remember? These lines? Well, they're called edges. Okay? So each of these nodes, each node, is touched. What's the word? So they're, well, I'm not quite sure what the verb is. You know, what is it? I'm not a graph theory specialist. What does an edge do to the node? Touch it? Connect? I'm not sure. Anyway, but you probably guess what I'm talking about, right? So each of these nodes has a degree of 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. All right. Well, that's it for that session. Fairly short. I'm noticing already. I did a bit of stats for my own interest. I'm trying to guesstimate how long it's going to take me to do this whole course. And I'm doing about 1 page of the textbook, to 1 session. In other words, 2 squares. So 400 pages still, 400 sessions like this. It's going to take months. Okay, so